Guys, so welcome back once again to my channel. I've been taking the incident responder area at um on Let's Defend, and it's been a very interesting pathway. Yeah, and how contextual the pathway is very commendable, as well as the labs, the investigations that one needs to do. Okay, because that is even what I value the most. Although there's the theory aspect of it, like understanding whatever, putting it into practice, I believe what's builds the experience, right? So in this video, I would be solving this challenge with you all. So the challenge is on memory analysis. Um, I don't know if this is visible. Let me. So the scenario we have here is a Windows endpoint was recently compromised, right? Thanks to a cutting-edge EDR solution, we immediately noticed. The alert was escalated to the incident responders for further investigations. Now, as a forensics guy, um, we are given the memory dump of the compromised. Then we need to investigate this incident, right? So um, I have found the machine already. Yes, so these are the questions that come with the challenge. Before that, oh, I'm keen on documentation as well, so I've already started something over here. Okay, so I have the wow, I made a mistake over here. Right. So let's defense challenge on this, and I have my scenario right there. So I'll be adding my questions as well, but just so that I don't waste too much time on the video. I would be documenting once I'm done with it. I think we can start with the investigation. So let me think. Challenge file is okay. So that's the memory dump. So before we dive deep into the challenge, okay, let me try and then establish some kind of a baseline. At least anyone watching this video will to understand what is happening. Let me start off with what memory analysis in general. When we talk about memory analysis, it's just the analysis of volatile data captured in a computer's memory dump. Okay, so if you talk about if you take the word volatile, okay, like we take it as a standalone component. Volatile here means that once your computer or the machine you are using is turned off, okay, you lose all data, right? That's what the term as volatile. So data is completely lost once the device is turned off or shut down. You can recall the fact that in cybersecurity, okay, it is always good that if an incident occurs, right, the affected device, host, server, talking of the affected device, right, it's not supposed to be turned off like automatically. Although in the early stages of an incident, okay, there might be that kind of uh, confusion, or you might not know what to do at that time or at that point in time, right? Okay, that is also the reason why there are frameworks, okay, to guide in terms of such happenings, right? So this is the scenario I'm creating over here, that it is always best to contain or isolate, or let me say in other words, isolate the host when an attack occurs, right? Because isolating the host is just you putting the host aside, okay, like isolating it from the rest of the network, but then keeping the volatile data intact, okay, so you don't lose any kind of volatile data. Now, in the early stages of an incident investigation, okay, once an alert has been escalated, and then it's time for forensic analysts or incident responders to investigate deep into the incident, right? There's the need to collect artifacts, right? But most of the times, these artifacts may be time-consuming one, and then it takes time to grab those artifacts. But one of the fastest approach, okay, is to look at the memory dump, right? Because it is something that can be accessed, within the shortest possible time, and also it gives you like a brief overview of whatever had been happening, like on the host, okay? Because every running program has to reside in the memory, right, for it to execute, for which reason makes the RAM a very important source of valid data, or to say artifacts, okay, to try and help analysts connect the dots when an incident occurs. So that was just, by the way, that was um just for everyone to understand what we are up to right here. So this is the memory dump that we are working with. Okay, let's then check the first question that we are being asked. We are being asked that what was the date and the time when memory from the compromised host was acquired, right? And you can see our format over here. Now, to answer this specific question, okay, we are going to fall back on tools that can help us to analyze memory dumps, such as Volatility 3, Volatility 2, right? But we are basically going to concentrate on Volatility 3. So let me go back to the terminal, right? So I'm going to use Volatility 3. So that's just the vol over here. Then I'm going to specify my file. That's the dump.mem. Then, this tool comes with various plugins that helps us to, or that will help us to solve this challenge. But not just to solve this challenge in terms of real world scenarios, right? These are the same steps that are being taken into um, for forensic analysis, right? So after we specify the tool with the file, that's this memory dump. The first question asking us to get the date and time when the memory was compromised means that we need some kind of information, okay, behind this uh, memory dump, right? Hence, one of those plugins is the info plugin that will help us to gather system information, okay, from the memory dump, right? So this command over here uses volatility 3, specifies the file dump.mem, that's the memory dump, okay, and then uses this windows.info plugin to extract system information from this memory dump. So I'll hit enter. You can see it gives us some kind of metadata, okay, metadata behind the memory dump, right? We're able to see a whole lot of information, but then we are mostly looking for what the first question asked us, okay, date and time when the date and time when memory from the compromised endpoint was acquired, and then that is visible um, right here. So that's the system time right here. Okay. Let's copy that and see if that is the correct answer. Like paste that in there. Right. So they are telling me I'm already on a 1 day. So I lost my 14-day streak. That was yesterday. I lost that streak yesterday because I had to meet my supervisor, and then I was very very much stressed out. Working on my final year project for school. So yes, we've been able to correctly identify the date and time when the memory from the compromised host was acquired, right? Now the second question asks us that what was the suspicious process. Okay, so let me copy this. I told you I was keen on let me put this. I think let me just use Yes. So the second question asks that what was the suspicious process running on the system, and it gives us the format as well. Now, to find the suspicious processes running on the system, right, what we are going to do is to utilize another plugin. So this time around, we're not going to use info. We're going to use pslist. Okay, it lists the various processes that are running. You know, um, okay, like in terms of the memory dump that we are analyzing. So I'll hit enter. The tool does its thing, and then we are presented with a whole lot of processes that are running. So see the process ID, parent process ID, the image file name, the offsets, threads, handles, and then so on and so forth. But we need to identify what is malicious over here. Any malicious code has to actually run as a process, okay, to do its work, right? And then for this process to also run, okay, the related instructions must first be copied to the RAM. Now, what I want us to note over here is that once we are looking at the processes running, or we've been able to list the processes, how are we able to identify what is right, what is not right? Okay, how are we able to spot those differences? So let me go back to my I think I let me do this with this wow. So what we need to so for okay, in order to better identify malicious processes, so what we are going to do is to look at malicious or suspicious process names. So the reason why I'm saying this is, sometimes process names could be your first alert. Okay, so if you see suspicious processes, from like tools such as Metasploit, right, it just gives you that idea already that there's something wrong with. But aside to that as well, you can also look at suspicious parent-child relationships. Right, I made a mistake. Sorry. To suspicious parent-child relation. So for this, I remember I analyzed a phishing attack that's or incident that occurred some months ago, and a clear example I can bring here is how suspicious parent-child relationships can be. Okay, because why should we, let's say, um terminal, okay, the terminal um as a child process of perhaps calculator, okay, like it kind of raises some suspicions, right? Because for calculator, it, what does cmd.exe got to do with calculator, right, running as um uh, like a parent and then a child process. So from that, you're able to get that kind of thought that there's something wrong. Okay, or also let's say Microsoft Word spawning a child process like PowerShell, right? It's suspicious because what relationship do those two processes have together that Microsoft Word has to be the parent process of PowerShell? It doesn't happen that way, right? The next thing we can also look at is broken parent relationships. Ships. So with the broken parent relationships, okay, it requires us to, as analysts, to be able to identify okay, what is right and then what is not right. Okay, so that is knowledge with processes, legitimate Windows processes. Okay, so you knowing these legitimate Windows processes, okay, you would be able to better define a rogue one when you see it. Okay, then the last thing would be advanced. So I call it advanced methods. Sorry. Um, so under this, you could have um, process injection. Could also have it's I quite remember DLL injection and and process following. So these are all defense evasion mechanisms that an attacker will try to employ, right? page detections. So let's just go back to the question, right? So what was the suspicious process running on the system? Now with these listed out, okay, let's just go back and then see if we can identify some suspicious commands, sorry, some suspicious processes that are running. So going back, um this becomes a bit difficult, but we can do this, right? So my first thing is to identify, legitimate Windows processes that um might no legitimate Windows processes that might have rogue parent-child relationships. That is what I'm trying to identify over here now, and you can see from here SV. So it's normal to see, a couple of, I think you need to see about 8 or more. I think, yeah, but SVC host, okay, it's very very much normal to like um a couple of them, right? I can see that the parents process ID is 608, and process for 608 services.exe, which is the normal which is like how normally it should be. This is very very much. And let me go down. Specifically interested in um various processes that malicious access tend to normally be in evading detection. So we can also see LSAS over here. So the process ID is 759 with the parent ID 3996. Okay, so let's see. Um, for 3996, which parent is that? Yeah, so 399 explorer.exe. Um, then there's something wrong, because why do I say this? Because normally, so LSAT's a legitimate Windows process, okay, designed for credential management and security policy enforcement in Windows. It's a very very much critical process for Windows. Okay. But what drew my attention to this was the fact that looking at the parent process being explorer.exe, so I saw it somewhere here. So this is it. It's not quite right, because the only parent process for LSAS has to be wininit.exe. Okay, and then even with that, so let me try and then see if we can get something else. Let's see. Really, so we also got another else. So this is like, we being able to spot, okay, like a rogue process, okay, because LSAS got to be just one it's just one LSAS process that has to run, and then even with that one, it's supposed to have a parent process of wininit.exe. Now let's see, this has this process ID of 640 with a parent process of 500. Now let's see what service or what process has the process ID 500. It's wininit.exe, which is the legitimate parent process for the LSAS process. Okay, so what we can infer from this is that there is one rogue process over here, which isn't this specific process, but the one we saw down there. Okay, um, that had the parent process to be explorer.exe. So what this can tell us is that, okay, explorer.exe is is related to the file explorer, okay, or let me say file manager, right? So if indeed shell code was injected into this legitimate process, this is just like saying you definitely need to know what is normal, okay, to be able to spot what is not normal. So from this, we've been able to spot that there is a rogue LSAS process running. So what I'll do is to okay, let me go back to the question actually. What is the suspicious process? So let me just put in lsas.exe. See, right, so that's the suspicious process that was running. Now even to get, or should we just move on? All right, I think the next, let me for documentation's sake, I think I would do this. Yeah, so those are the command we use for the earlier question, and uh, the third question is asking us to analyze and find the malicious tool running on the system by the attacker. So this is the format, right? So what I'll do is to use another um, plugin. So I would like to, once I've been able to identify that there is a rogue process running, okay, I'm going to um, investigate with the um, uh, CMD line. CFD, sorry, I'm going to investigate with the CMD line plugin. Okay, so let me this CMD. So since the rogue LSAS process indicated that the parent process was explorer.exe, it just tells me that it's likely someone executed a bad file from the file explorer. Okay, so what this command does here is still uses the volatility 3 to specify the memory dump file, and this time we are going in with the CMD line um uh, the CMD line plugin, but I would grep this to the rogue process ID. I'm going to grep it to 7592 7592. Sorry, so what we are trying to do here is to kind of um inspect the command line argument associated with that specific process. So now you can see what was returned. Okay, so this is the part. Okay, I think this is also another interesting thing to find, because normally okay, this specific LSAS process, it runs from the system 32 directory, right? Not system directory. So I think this is also some information that is worth noting. Okay, which is telling us that indeed this process is a root process. But the third question is actually asking us to identify the specific, you know, um, uh, malicious tool that was run by the attacker, okay, on the system, right? So since you are not able to get as much information from the command line arguments, right, I think the best thing now would be to dump, okay, the the process. Okay, we are going to dump it. So I'm going to now use the pslist command. Sorry, pslist. Then I'm going to dump it. I'm going to specify the process ID 7592. Right. So this command just dumps the processes. Or let me say, it specifies the specific rogue process, right, and dumps it so that we can be able to use that to maybe perhaps query, threat intel platforms to identify the specific tool, okay, because it seems like this tool has been maxed, right? So I'm going to hit enter and see what we get from here. So this is the dumped file. If I hit ls, so yes, this is the file we just dumped, right? So what we're going to do is to instead of just uploading this file to perhaps threat intel platforms, what I'm going to do is to calculate the MD5 hash. Go to the command ISA. I'm going to specify the file, hit tab to then hit enter. So now this is our MD5. So I'm going to copy this and go back to what I'm going to do is to query we have search results dating back to 2024, think downwards. So let me open this for submission. So this is the submission was submitted at or on 300% malicious. So you can see what we are driving at. From the processes that we listed, we identified a root process, then we dumped we dumped the process, okay, the root process, okay, and then we are now trying to find the tool, okay, that was, in quotes, maxed, right? So let's just see if we are able to identify any tool name. So I don't think a good analyst has something to go back to. So this says the risk assessment is where it has some kind of technology or technology found officials. So everything drives at malicious nature of this specific file, right? It reads VM specific it also reads the registry for VMware specific artifacts, but the Yara Picards, Celsius, MD or SD. Let me go back and check format, because if we are being told over here there was a Yara signature mark, we all know that that is a credential dumping. Let me just try and this will go back. Oh, so that's not true. Let me just go back. Let me just use virus as well. See what it has. So VirusTotal also had a very critical detection rate. Many of these vendors detected this file as malicious, and wow, oh, so that's the file name, right? Let me try that. The WinPiece is it's a Windows privilege escalation tool, just as we have Linux systems penetration test that is elevate privileges to perform privilege escalation, to abuse your privileges that you have over a system. I'm definitely confident that this will be the tool. But let's see what others have come. APT Pana Tosca. Right. Let's just check some kind of CVS. So let's just put in this for our third question. Right, so that's the one. I think just quick. And oh, okay, so it seems like I already have the question. So let me add dump file, malicious file, and calculated its VirusTotal. Then let's move on to the fourth question. Which user account was compromised? You have the format also. Let me copy it. of our question. Now, how would we go about this as well? So, which user accounts was compromised? So, in this case, we are trying to get information with regards to the specific user account or system related details about the accounts that was compromised. There might be the possibility that there were different kind of accounts on the system, but then from which account was this privileged access abused, right? So we are going back to our terminal. Okay, so back in the terminal, we are now going to use so let me just click. I'm going to use the first. So what this plugin does is gets us some kind of system configurations is related point. Hopefully we are able to find the associated accounts that was compromised. So after running the command, get the able to see so not only the user account, user domain, username, cyberjunk. This is the full approve. And what we are being asked of is user domain, username. I'm going to copy in that. Go back. So format is mainly slash right. That was right. So let me go and then change. What is the compromise password? So definitely you would need to do a hash dump for the compromise. So going back, we of the then going to hash dump. Just basically hash dump plugin hashes. So this command returns. Let me just copy the quickly. So yes, I have it. I think later when I'm done with the video, I would like kind of add some kind of explanation commands. So this command has returned to us two different hashes. We have the LM hash and the hashes. We have that for this administrator, yes, have the default accounts, so on. Cyberjunk, but you tested in Cyberjunk. Now you might ask that what's the difference between the LM hash and it? These two hashes, right? LM hash and they are cryptographic methods that are used to store credentials. Then they may differ like in terms of looking at it from this, also from the how it was designed. That is just basic explanation. Procedure go back on NT, or in other words NTLM. You are most interested. So once you'll be able to dump the hashes. What's need to do brute force the hash. Okay. So we are going to try as many combinations possible to crack the specific hash, which would give us access to the user's password. Once we are able to crack this hash, being able to get the password of CyberJunkie account. I think we can use Hashcat, perhaps John the John the Ripper. Let me see if it is. Yes. So it seems like it's not installed. Hashcat is off. Let me make sure that's something. I think an alternative way would be open up my Kali Linux premium, since that's already fine. All this volume. I'm going to go back and add some more testing. Okay, so I already added, just so that I'm not disconnected SSH connection. It seems like Hashcat is now installed. Hashcat help. Right, so Hashcat is now. Let me go back. I need to copy the NTLM hash. So this is it. I'm going to copy that. I'm going to echo this. I don't think okay. I'm going to, what this command does is put this specific text hash into NTLM.txt. So once we have our hash within this file, we're going to use Hashcat to brute force it, find the credential that matches this NTLM. We're going to compare this against a list of passwords. Perhaps we'll be using work unit. We're going to enter NTLM.txt. We're going to see now the command I'm going to specify. So what is that is to tell Hashcat that we are looking to so we are just specifically telling Hashcat this target signature with this specific text file. So text file is to just basically tell Hashcat that this is how it should see the hash with right, specifying the hash type command. Now we'll now specify. I even check if this system has the Linux system. We mostly have our dictionary of share word list. So it seems like it doesn't even have the word list. Okay, so what do? I think it will be best for me to at least let's see. I think let me just do work you text. Those be this. So but in the system we are using doesn't have the text file. That's the tip. So I think I need to hit the OQ.txt. This is so we have the file here. Let me calculate it. just to cross check it. Thinking from the, let me go back to the complete good if. So I'm going to unzip this file. So now we have a text file. Let's share and cut it to text. But that's the right text file. What I'm going to do, working the copy this right now, go back to so this is where we have our, so what I'm going to do, Hashcat, as I said earlier, which is better this, go to pasting. Sorry, so before the dictionary file, I have to specify the hash that I'm trying to crack. So that's the NTLM. Then I specify my dictionary file, run it. Is not a native install open runtime, expect massive speed loss, can use that cause to write. So let me, so let's just hold on, see how it goes. Right, so from here, we have some kind of data with regards to input we give Hashcat. Let me just start from, so this is the dictionary patch that was built. We have it stored with found passwords or then at this side we can't see session, that's what, but hash type is LM, the hash target, that's the hash had in the LM text. The time it started, time it just took about 1 second to crack password, right? Then what else do we have here? So dictionary cache, I think it's the same information. So here you can see how the status is what cracked, which means that we've been able to crack the hash, which gives us the password to cyberjunkie, right? Okay, so from here you can see the candidates over 1, 2, but what we actually pointing the hash that we set to the specific password, which is a password found it also dictionary password would be better. Password cracking it. I'm just going back to so that was the right approach towards this challenge. I think that anyone watching this pointing can be able to not just guess what done and some kind of resource help you out. It was a very nice challenge. As I said, refining also upload the account. So I think this will be as much so take video period or maybe next challenge alert that I